Today we'll be dealing with equations, graphs of equations in two variables. We have to remember that the solution of an equation is the set of all of the ordered pairs that make the equation true. That can be many different x values and many different y values. Sometimes we have to check them, but most of the time we can find a pattern to very easily graph these things. In examples 1 through 3, we're going to use a t-chart to graph 3x minus 2y equals 6. Hopefully, you guys will recognize that that is the equation of a line. In example 2, we're going to use a t-chart to graph the equation y equals 1/2 x squared plus 2. Again, since that is a quadratic with an x squared, we know that that should be or have the shape of a parabola or a U shape. Next in example 3, we're going to use a t-chart to graph the equation y equals x plus 1. Absolute value of that, minus 3. Again, from the past, we should remember that the absolute value shape is a V shape, and we're going to graph each of those using a t-chart. T-charts are very useful to try and graph these things, but again, any point that is on the graph of these equations makes that equation true.
In example 1, we're supposed to graph 3x minus 2y equals 6 using a t-chart. Probably the easiest way to do this is to rearrange the equation so that one of the variables is by itself, and probably getting y by itself is going to be the easiest. So we're going to subtract 3x from both sides to begin. That will give us negative 2y equals negative 3x plus 6. Then to finish getting y by itself, we divide everything by negative 2. And so that gives us y equals 3/2 x minus 3. Now to make a t-chart, we just choose whatever values of x that we need. And I'd like you to choose at least 3 different values. If you want to choose more, that's fine. But in this case, it's probably a good idea to choose values of x that are even. That way we can get rid of this fraction when we multiply it. So I'm just going to choose negative 2, 0, and 2. Again, it doesn't make any difference which x values you use, so probably just try and choose some that make your math easier to do. So if we choose negative 2, we see that y is going to equal 3/2 times negative 2 minus 3. So 3/2 times negative 2, the 2's will cancel. We get negative 3 minus 3 gives us negative 6. For the second one, this one will be easy. 3/2 times 0 minus 3. Well, 3/2 times 0 is just 0, so we get negative 3. And then finally, when x equals 2, 3/2 times 2 minus 3. Again, the 2's will cancel, and we get 3 minus 3. And that gives us the last value in our t-chart of 0. Once we have the x and y values, these are just ordered pairs. We can graph them on the coordinate plane. And if you want to use graph paper, I have some graph paper sitting up on the table over here. Otherwise, just drawing a sketch of it is probably going to be good enough. I don't need it to be perfect, but I do want it to be accurate. So if you put marks on your thing, on your graph, make sure that they're in the right spots. First we have negative 2, comma negative 6. So negative 2, negative 6 will be down here. Then we have 0 for x, negative 3 for y, that'll be there. And finally we have 2 for x and 0 for y, and that'll be right there. As we draw this, we see that that is the graph of this equation, 3x minus 2y equals 6. Another method for doing this particular problem is that this equation is in standard form. So when an equation is in standard form, we can actually find the intercepts very easily. If you remember, on the intercepts, to find the x-intercept, we know that y equals 0, and to find the y-intercept, we know that x equals 0. So if I want to find the x-intercept, I can just plug in a 0 for y. And we find out that will cancel out, and so 3x equals 6, x is going to equal 2. So our x-intercept is going to be the point 2, 0, which you can see is already on our graph. The y-intercept always happens when x equals 0. So if we plug in a 0 for x, then this cancels out, and we get negative 2y equals 6, so therefore y equals negative 3. The y-intercept being negative 3, notice that is also a point on our graph right here. And actually, if you use the intercept method, you're just going to get 2 points. But really, using the intercepts, that's easy enough math. You shouldn't make a mistake there. With a t-chart, it's a good idea to do 3 points, just to make sure you haven't made a silly mistake in your math somewhere. But either way, we're going to get the same line for example 1, and it's going to look like this. Positive slope, going through at negative 3, and then up through where x is 2. As we look at example 2, hopefully you recognize y equals 1/2 x squared plus 2 is going to be what shape? Hopefully you said that it should be a parabola. That's the word I'm looking for. So we know it's going to be a U shape. And from what you've learned in Algebra 2 or in your other math classes, this is going to be a U shape, and it's going to open up since this a value is positive. But again, we can get a good idea of what this looks like just by making a t-chart. So because this is a curve, we do need to choose a few more points. I like to use 0 because it's easy to work with. And then in this case, we want to choose small numbers because when you square them, the numbers get very large very quickly. So let's use 1 and 2, and negative 1 and negative 2. So just using that formula, 1/2 times negative 2 squared plus 2. Negative 2 squared is 4. 4 times 1/2 is 2. And then 2 plus 2 is going to give you a y value of 4. For the second one, 1/2 times negative 1 squared plus 2. In this case, negative 1 squared is 1, times 1/2 is 1/2, plus 2 is 2.5. Then we use 0. So 1/2 times 0 squared plus 2. Well, again, when you multiply by 0, that cancels, and we just get 2. Now, here's where the nice thing happens with parabolas. They are symmetric. So in this case, you'll notice when we put in a 1 and we square it, it's going to be the same as when we put in a negative 1 and square it. You're going to get 1. Multiply by 1/2 is 1/2. Add 2, 2.5. And then finally, 1/2 times 2 squared. You may have guessed this, but it's going to match up with this. 2 squared is 4, times 1/2 is 2, plus 2 gives you a 4. So here are our 5 ordered pairs. And when we graph this one, we get the point negative 2, 4, negative 2, 4, then negative 1, 2.5, 0, 2, 1, 2.5, and 2, 4. And so even though my graph isn't perfect, we know what the shape is. It's a U shape, it's a parabola, so we're going to get a graph that looks like this. So we're going to do one more example making a t-chart with absolute values, but pretty much if you can use a t-chart to graph a function, you can graph pretty much anything just by choosing your x values and then finding out the corresponding y values. In this example, example 3, we're going to do an absolute value problem. Y equals the absolute value of x plus 1 and minus 3. Again, we just need to choose some values of x. Absolute value, if you don't remember, absolute value has a V shape, just like a quadratic has a U shape. So we know this is going to be a V shape. We just need to choose whatever values of x that we want. Let's just go with, again, 5 of them, negative 2, negative 1, 0, 1, and 2. I tend to keep those small, just again, because small numbers are usually easier to work with. So for this first one, we have negative 2 plus 1, the absolute value of that minus 3. Negative 2 plus 1 is negative 1. The absolute value of negative 1 is positive 1. And then positive 1 minus 3 is negative 2. For our second point, negative 1 plus 1 minus 3. Well, negative 1 plus 1 is 0. Absolute value of that is still 0, and then we subtract 3. When we put in a 0, 0 plus 1, the absolute value of 0 plus 1 is 1. And then 1 minus 3 gives us negative 2. So notice these two end up being the same, and since we know V-shapes are symmetric, that should give us an idea of what's going on here. When we use the 1, 1 plus 1 is 2. Absolute value of 2 is still 2. Minus 3 gives you negative 1. And then lastly, 2 plus 1 is 3. Absolute value of that is 3. Minus 3 is 0. So we've got these ordered pairs, and what we'll see here is putting these on our graph. Negative 2 comma negative 2 is right here. Negative 1 comma negative 3 is right here. 0 comma negative 2. 1 comma negative 1. And 2 comma 0. Now again, we have the advantage of knowing that this is a V shape, so the bottom of our V is right here and goes that direction. That means the other one is here and is going to go out this direction. Every absolute value will have a V shape. The key is to try and find the vertex where that V changes directions.
Our next topic is the intercepts. And when we're dealing with intercepts, we need to keep in mind that the x-intercept is any point where a graph of an equation intersects the x-axis. The biggest thing that we have to remember about that, sorry about that little sound, something was recording in the background. The biggest thing we want to realize about that is that the x-axis always occurs when the y value is 0. So the ordered pair for any x-intercept is always going to be some value for x, and we call it a, comma 0. The y-intercept is going to be very similar, but it is a point where the graph of an equation intersects the y-axis. Again, this always happens when x is 0. So the ordered pair for a y-intercept is always going to be 0, comma something, and we just use a b to represent that something. Now we're going to take some time to find the intercepts, the x and y intercepts of the equation y equals negative x squared minus 2x plus 3. I'll give you just a second to copy that down before we shift to the video of that example.
In example 4, we are supposed to find the intercepts of this equation. This again, since it's x squared, it's a quadratic, which means the shape is a parabola. So it will have one y-intercept, and it might have, we don't know, but it might have two x-intercepts. It might have just one x-intercept if that's right on the vertex, or it's possible that it doesn't have any x-intercepts. But again, just like when we talked about the linear equation that was in standard form, when we want to find the x-intercepts, those always happen when y equals 0. So we can rewrite this equation as 0 equals negative x squared minus 2x plus 3. Now we've solved equations like this. We solved them in chapter 1, the last chapter that we just did. What we want to do is try and factor this. But the first thing we want to do, we want that x squared to be positive. So we're going to factor out a negative 1 from everything. And what we have left is x squared plus 2x minus 3. At this point, we just want to try and factor it. The 0 and the negative stay there. We're going to have an x and an x. Remember, what does this sign tell us? It tells us that the signs have to be different. So we're going to have one positive and one negative. Then this one tells us that the larger value is going to be positive because we need two values here that will multiply together to be negative 3 and add together to be positive 2. And our only options there, since 3 is a prime number, we have 1 and negative 3 or negative 1 and positive 3. And in this case, the one that works is where the 3 is a larger number, and it's positive. So once we know that, to solve this, you remember you said each factor equal to 0, so x plus 3 equals 0, x minus 1, x minus 1 equals 0. So in this case, x equals negative 3, and here x equals 1. So that means our two x-intercepts are the points negative 3, 0, and 1, 0. Finding the y-intercepts is usually easier because the y-intercepts occur when x equals 0. So we have y equals, and we just replace all the x's with zeros. Negative 0 squared minus 2 times 0 plus 3. Well, like I said, this is going to be easier. 0 squared is 0, negative 2 times 0 is 0, and all we have left is 3. So the y-intercept is going to be x is 0, y is 3. So those are the three intercepts that we have, two x-intercepts and one y-intercept.
As we've seen, the y-intercept of that equation is 0, 3, and the x-intercepts are negative 3, 0, and 1, 0. Now, the equation of a circle. We see circles all over the place. The equation of a circle is actually fairly straightforward if you keep in mind three different values. And the three different values are the h value, the k value, and the value of the radius. So first of all, we have a circle. The circle has a center of h, k. So our x value is h, our y value is k. It has a radius of r. The standard form then for this equation is going to be the quantity x minus h squared plus the quantity y minus k squared equals r squared. As you look at this, you might realize, and it's a very good thing to realize, that right here we see that x minus h corresponds with an h value, an x value for the center of h. These two will always be opposites. Right here we see y minus k. That corresponds with the center value for the y coordinate of positive k. These two will also always be opposites. That's going to be very important for us as we go through and work with these equations and the graphs of circles. We're going to take a minute to graph these two. X minus 3 squared plus y plus 2 squared equals 4.
In the first part of example 5, we're supposed to graph this equation. We just learned the formula for the general form of a circle. As we can see, this is a circle. Okay, we have this thing squared plus this thing squared, and it equals the radius squared. So the first thing we want to look at is the center of our circle. The center of our circle, we find the x value right here. It's the opposite of what you see here. So if you see x minus 3, your center is going to be an x value of 3. Or is going to have an x value of 3. Right here, the same thing happens for y. When you see y plus 2 in that parentheses squared, your center is going to have a y coordinate of negative 2. So we know right away that our center for our circle is going to be the point 3, negative 2. The other thing we have to look at is the radius. And the radius comes, we get that information from over here. The basic equation for a circle has the x stuff squared plus the y stuff squared is equal to the radius squared. So if the radius squared equals 4, we know that the radius in this case has to be the square root of 4, which is 2. You're going to have to pardon my picture. I can't draw great circles, but here's the idea. Our center, 1, 2, 3, 4, 5, is going to be at the point 3, negative 2. So there's the center. The easiest way that I know to graph a circle, since I know the radius is 2, that means in every direction you're going 2 units from the center. So I go up 2, I know that's a point. I go to the left 2, that's going to be another point on the circle. I go down 2, that'll be another point on the circle. And then I go to the right 2, and that'll be another point on the circle. And then I just try and draw a curve as well as I can through these 4 points. And so that's a circle. It's not a perfect circle, but that's the basic equation. What I'm going to look for when I'm grading your graphs with circles is I'm going to look for where is the center and do you have the radius marked off correctly. I'm not going to worry about if it's an exact circle, because to draw an exact circle is virtually impossible.
Now we will graph x squared plus y squared equals 49.
In the second part of example 5, again we have the equation of a circle. But this time it's a little bit different. In this case, as we look at this, and you have to kind of think about it this way. Once you see it once, you'll probably know it after that. But this is really x minus 0 squared plus y minus 0 squared equals 49. Which means the center of our circle is going to be an x-coordinate of 0 and a y-coordinate of 0. It's going to be at the origin. The radius, again, is going to be equal to the square root of 49, which we know is 7. So to graph this, our center is at the origin. We know we have to go 7 units in each direction, so there's 1, 2, 3, and those are 4 points that are all going to be on our circle. Again, the bigger the circle gets, the more difficult it is to try and make a perfect circle, but we'll just do our best and make a curve through there. And you can all start laughing now because I see it looks pretty oblong. But there's your circle. Center at 0, 0, the origin. The radius in each direction ends up being 7 units. So circles, once you get them in the standard form like this, they're pretty easy to deal with. You can find the center easily, and then you can find the radius easily as well.
As we look at example 6, we are trying to find the equation of a circle with a center of -5, 6 and a radius of 9.
The first part of example 6a is very straightforward. They give us the center of a circle, they give us the radius of the circle, and they want us to write the equation out. Well, we know that the basic equation for a circle is the x stuff squared plus the y stuff squared equals the radius squared. And if you remember, the value that goes in here has to be the opposite of your x-coordinate here. So that means this is going to be x plus 5. That moves the center of the circle 5 units to the left. This one has to be the opposite of that, so we're going to have y minus 6. The last thing we know is that this value over here is equal to the radius squared. So if our radius is 9, we know that the value that goes here is going to be, and I know you all said it, 9 squared is 81. So that is our equation for example 6a. Very straightforward. If you know the radius and you know the center, it's very easy to find the value there, or find the equation for a circle.
As we can see, that should have an equation of x plus 5 squared plus y minus 6 squared equals 81. Example 6b, we're finding the equation of a circle with a diameter that has endpoints -5, 6 and 1, 8.
Example 6b is a little bit more difficult than example 6a. And the idea that we have here, they tell us that the endpoints of this circle, of the diameter of this circle, are the points 1, 8 and -5, 6. Now without even drawing that, if I know the endpoints of a diameter are wherever, I know that the center of the circle has to be the midpoint of that diameter. So the first thing I would do is find the center of your circle, because we're going to need that for the equation anyway. If you remember the midpoint formula, our midpoint is going to be equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And as we see this is -4 over 2, which is -2. And this is 14 over 2, which is 7. So -2, 7 ends up being the center of our circle. Next we have to find the radius. So finding the radius, or we need to find that value, we need the radius squared, one or the other. So finding this is a little bit more challenging. We have to use the distance formula. So we're going to find the radius, that's the distance from the center to either one of these points. And it doesn't matter which one you choose, just pick one of them. So let's go ahead and just choose the first one. So my radius is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Remember that this is subtracting a negative, so it makes it positive. So now we have r equals 3 squared plus 1 squared. Now the nice thing here is this is going to be equal to 10, or the square root of 10. But remember that in my equation, on the last part of the equation, we need r squared. So if r is the square root of 10, r squared, we square this side, we square this side, r squared is going to equal the square root of 10 squared, which is 10. So since we know r squared and we know the center, now we can write out our equation. Remember, it's the x stuff plus the y stuff equals the radius squared. We know the x value has to be the opposite of this, so it's plus 2. The y value has to be the opposite of this, so it's minus 7, or negative 7. And then lastly, our radius, we've already squared it. This is the radius squared, and that's going to be 10.
This equation, finding the center and then the radius, gives us, or this problem gives us the equation x minus 2 squared plus y plus 7 squared equals 10. Finally, we have example 7. We're supposed to rewrite this equation in standard form. I suppose we need the equation. There it is. X squared plus y squared plus 4x minus 8y plus 3 equals 0. We'll take time to figure that out.
Here in example 7, we can see probably one of the most challenging problems that you're going to have on your homework tonight. It's an equation that is given to us, and it actually is the equation of a circle. They'll tell you in this section that it's the equation of a circle, but it's not written in standard form for a circle. So our first goal is to rewrite this in standard form. To do this, we have to go through the process of completing the square, which we talked about in the last chapter. I told you you'd never have to solve an equation using completing the square, but it is used a lot in rearranging things that are called conic sections, which are things like circles and parabolas, and then some other things that we won't talk about in this class, like hyperbolas and ellipses. Those are the conic sections, and that's where we use completing the square a lot. But the first thing we're going to do, just like in completing the squares, we're going to get rid of that constant term. And so we're going to have x squared plus y squared plus 4x minus 8y equals negative 3. We're just going to move that over to the other side. Then we want to group the x stuff together. X squared plus 4x, and I'm going to put that in parentheses here, plus, and then we're going to have the y stuff. Y squared minus 8y, and we know that that still equals negative 3. Now, if you remember the process of completing the square, what we have to do is take half of this b value, whatever it is, we take half of it, and we square it and add it here. So half of this is 2, so we're going to add 2 squared right there. Since we're adding 2 squared on this side of the equation, we also have to add 2 squared on this side of the equation. So we have to make sure whatever we do to one side of the equation, on the left side of the equal sign, we have to do the same thing on the right side of the equal sign. If you look at this one, we have to take half of negative 8. Half of negative 8 is negative 4, and we need to square that also. So since we're adding negative 4 squared on the left-hand side, we have to add negative 4 squared on the right-hand side. Now we have just created a perfect square here and a perfect square here. This one, as a perfect square, if you remember, it's always this value comes down here, that's the x. This value comes down here, that's the 2. And it's a positive 2, so that becomes x plus 2. In this case, for the y stuff, our perfect square, again, the y value comes down here. And in this case, it's a negative 4, so that becomes minus 4 right there. That's why I leave it at just as, instead of putting a 4 here, even though we know 2 squared is 4, just leave that as 2 squared, and just leave this as negative 4 squared, because these are the values we really care about down here. On the right-hand side, we have negative 3 plus 4 plus 16. So to finish this off, we have x plus 2 squared plus y minus 4 squared equals negative 3 plus 4 is 1 plus 16 is 17. If you remember, that means our center of our circle should be the opposite of this, which is negative 2, the opposite of this, which is positive 4, and then our radius, in this case, is not a very convenient radius, but our radius is the square root of 17. It's just, since that's r squared, our radius is the square root of that. We're not going to take time to sketch that, because the square root of 17 would be a little bit messy, just because it's not a nice even number. But we'd go through the same process. Find the center, negative 2 comma 4, so 2 to the left, 4 up. And then this radius is almost exactly 4, so the radius would be just a little bit more than 4 in each direction. But again, the process of completing the square, you may have to rewind this and watch this again to make sure that you're understanding the steps and what I said and what's going on here. But the process of completing the square, it's just the goal is to make this x stuff into a perfect square and this y stuff into a perfect square. And then remember that whatever you add on the left-hand side, whether it's the 2 squared or the negative 4 squared, you also have to add that on the right-hand side.
As we can see, again, we get x plus 2 squared plus y minus 4 squared equals 17. The process of completing the square, we do use that, not to solve, because we have an easier way to solve, but we do need it in order to rewrite some of these equations. Symmetry is the next topic we want to discuss, and we have several different tests to use in order to find out if something is symmetric. So to test for symmetry with respect to the x-axis, we check to see if the equation is unchanged or equivalent when y is replaced by negative y. You'll see an example of this in just a second. To test for symmetry with respect to the y-axis, we check to see if the equation is unchanged when x is replaced by negative x. Finally, to test for symmetry with respect to the origin, we check to see if the equation is unchanged when x is replaced by negative x and also y is replaced by negative y. Okay, we're going to test a couple of equations here. And we'll stop for the video to show the examples of testing for those.
In example 8, we're supposed to test this equation, x equals 2y to the 4th power, for symmetry. And remember, there's 3 types of symmetry. We have symmetry with respect to the x-axis, symmetry with respect to the y-axis, and symmetry with respect to the origin. As we look at this, to test for symmetry with respect to the x-axis, we replace the y value with a negative y. So replace y with negative y in the equation, and then we just simplify it to see if this is exactly the same or exactly equivalent to that one. Well, 2 times negative y to the 4th power. Negative y times negative y times negative y times negative y. That's 4 negatives, which means our product there, as we learned in the last chapter, is going to be positive. So we get x equals 2y to the 4th power. So right away, we know this is symmetric with respect to the x-axis. But we're supposed to check with respect to every axis. So next, to check with symmetry with respect to the y-axis, we replace x with negative x. We don't change the other stuff. As you can see, the right-hand side has not changed. It's exactly the same. The left-hand side is now negative. These equations are not equivalent. They're not the same. And so there is no symmetry with respect to the y-axis. Lastly, we have to check for symmetry with respect to the origin. And when we do that, we replace the x with a negative x, and we replace the y with a negative y. Well, we've already kind of done both of these things before. This one, nothing happens. It stays as negative x. This one, when we take negative y to the 4th power, becomes 2y to the 4th power. So as you can see, this one and this one are again not the same, so there is no symmetry with respect to the origin. And that's example 8, testing on symmetry. Anytime you test for symmetry, you have to test each type of symmetry, because sometimes certain equations can have more than one symmetry. It could have 2 of them, or it could even have all 3.
As we see in the video, we find out that this equation is symmetric with respect to the x-axis. In example 9, we're testing this equation, x squared plus y squared equals 25.
If you look at this, example 9 gives us a circle, and we are supposed to test for symmetry. Since it's a circle, circles are many times very symmetric, depending on where their origin is. So let's just start out testing for symmetry with respect to the x-axis. To test for symmetry with respect to the x-axis, we replace the y with a negative y in the original equation. So now we have x squared plus negative y squared equals 25. Well, negative y squared, negative y times negative y, 2 negatives, you get a positive y squared, and notice that this equation is equivalent to this equation. So yes, there is symmetry with respect to the x-axis. After that, we can test for symmetry with respect to the y-axis by replacing the x value with a negative x. Well, notice what happens again. Negative x times negative x is x squared plus y squared equals 25. So we find out that this equation is equivalent to this equation. So yes, there is symmetry with respect to the y-axis. And finally, we'll test symmetry with respect to the origin. So we replace the x with a negative x. So we have negative x squared. We replace the y with a negative y. That gives us negative y squared. And then we simplify. So this, negative and a negative, gives us positive x squared. Negative and a negative again gives us positive y squared equals 25. And notice in this case, all 3 of them are equivalent. So there is symmetry with respect to the origin, the y-axis, and the x-axis. If we think about this, this is the equation of a circle with a radius of 5 and a center at 0, 0. So it would make sense as we look at this, pretend that's a good circle, but it would make sense that it's symmetric about the origin, which is a turn of 180 degrees. It's symmetric about the x-axis, which is a reflection over the x-axis, and it's a symmetric over the y-axis, which is a reflection over the y-axis. So some shapes do have multiple symmetries, so you do have to check all 3 when the directions say to check the symmetry.
In this case, we find out that not only is it symmetric with respect to the x-axis, like in example 8, but it's also symmetric with respect to the y-axis and the origin. Your assignment for section 2.2 is page 167, numbers 7 through 10, 12, 16, 17, 28, 34, and 40. You will have time tomorrow in class, if I'm not here, to work on this assignment. I know this lesson went a little bit long, so maybe you're finishing this up on Tuesday. But either way, you have Tuesday to work on it, or the remainder of Tuesday to work on it. That assignment will be due on Wednesday, and we will start section 2-3 on Wednesday. So enjoy that. You can work. You can ask questions of each other. I think that probably some of you will understand this very well. Some of the rest of you may become a little bit more difficult, but if you want to help each other out on Tuesday, that is just fine with me, or the sub can help you as well. Have a good rest of the day.